morning, students.
Yes, sir.
How are you today? Busy as usual?
Yes.
Starting today, we will enter the new chapter, which is the matrix algebra. I'm sure that you have seen matrix a lot, yeah, in your previous classes. So we will learn about its fundamental theory in this chapter 7. So these are the list of topics that we will discuss in chapter 7. We will discuss first about the notation, and then probably today we will only discuss 7.1 up to 7.2 or 7.3. I'm not sure. Okay, so we will review again how we do mathematical operation on matrix, vectors. But your goal later is that so that you can perform this linear system of equation solving. Yeah, and to do that, you need to understand the basic theory on matrix, on the set, on vector spaces, linear independence, and many things. Okay, this one first. Notation is important, so we will discuss about notation. R in here refers to the real number. Okay, and if we have the power of n in here, it means uh, it is an n by 1 real vector. So for example, if I say R3, then I can write down that 1.3 minus 5, this is in R3. Okay, so basically if we are in R3, the first element, the second element, the third element, you can choose any number that is real number. Okay, which is why if we say in Rn, then we have n elements. Okay, the small n here refers to the natural number, and then the xi here is the real number. Okay, so you can choose any number for x1, x2 up to xn. Choose any number that is real number. Can you choose, for example, 3 minus 5i to be included in the Rn? Why is this?
It's not X.
It's a complex number. Yeah, complex number is not in the set of the real number. Yeah, so we cannot include this. Okay, this is not a real number. So you think that when we have a power in here, that means it is a vector already. Yeah, if it doesn't have a power in here, then it means it is scalar. Yeah, so this expression here discuss that if you have R2, then you only have 2 elements and each of them are real number. Okay, so if it is 2 elements, you can define these 2 elements in xy plane. Okay, and then we will see later then that this whole area here is called the R2 space. The space, yeah, we call it space because it looks like a physical area. We call it space. Yeah, let us discuss about this more precise set theoretic definition. So this is something that we can see physically. Yeah, physically, what I mean is that when we see R2 or R3, we have 3 elements on it. Yeah, choose each of the elements coming from the real number. But from the set theoretic definition, when we say R2, this is actually set theoretic cross product, but I don't think we will use this in the class. We will not use this, but just for the sake of completeness, technicality, correctness in mathematical definition, that actually R2 is R cross R, okay, and R3 just R cross R cross R again. The same meaning actually, yeah, that's the same meaning. The same meaning as you see here. Okay. Okay, let us see this. By definition, the matrix that you will see is a rectangular like this, a rectangular array of elements. If we say matrix A is in R 3 by 2. Okay, so when we define matrix, usually we will say it's a member of what kind of set is this? Okay. This corresponds to the rows, 3 rows, and number 2 is the column. So if A is a member of R3 by 2, then A can be get me like this, yeah, 3 rows, 2 columns. Okay, so if it is like that, then let's say this is a real number, then the A matrix in that slide is a member of what? R. How many rows we have? How many rows? M rows, yeah, from 1, 2, 3, 4, 5, then up to M. So it is M rows. M rows. How many columns? N columns. So it is M by N. Okay. So when you see subscript here, the first subscript refers to the row. The second one refers to the column. Okay. Any question on this? Yeah, it says that individual entry of a matrix is an element. Also, individual entry of the vector is also element. We call it element. Okay. Clear, Michael? Your name again? Johan. Okay, I remember now. Johan. Any question, Johan? No? Okay, yeah, we discussed about this just now. Horizontal set of elements is called row. So this is row, yeah? What is the first row of this matrix? 1 and 4. What is the third column of this matrix?
0, 0, 0, 0.
No, we have no, not 0, 0, but we have no third column. We don't have the third column here, not 0, 0, 0, yeah? Non-existent. Yeah, non-existent and 0 is different, yeah. What's your grade for quiz in week 3? 0, sir. What's your quiz? What's your grade in quiz week 3? When I ask to the student who doesn't come to the class, 0, not 0, but non-existent. They have no grade. Yeah. That's completely different meaning. Okay. Okay. 1 by n matrix, row vectors. What do I mean by row vectors? Row vectors is like this. Let's say you have 3.5 minus 9, 20. This is row vector. Okay, this is how many row column? 1. How many column? 3. So this is a member of 1 by 3. Okay, 1 by 3. So usually, if it is just 3 by 1, yeah, the 1 here is never mentioned. because it is clear if it is 3, then it is a column vector. It has 3 rows. But if you have row vectors like this, you have to mention the 1 by 3. Okay, any question on this? Clear? Yeah, now we have special matrix. Special means it has a certain format. Yeah, not just an arbitrary format. The first one is symmetric. What can you see here in a symmetric?
All the row and column have number.
Sorry, again?
All the slots are filled.
Huh?
All the slots are filled.
All the slots are?
Filled.
No, that's not symmetric means. What is the definition of symmetric? If you see from here?
Row and column has the same.
No.
The upper triangular and the
Say that again. Upper and lower one?
upper and lower triangular.
No. Yeah. Got it? No. Johan?
What symmetric means?
Yeah, what's the definition of symmetric?
Of the one is two separate ones.
Okay. Yeah, that's the same, yeah. So you see 1 to 7, 1 to 7, they're the same. So you see the diagonal? See the diagonal, yeah? They are mirrored to the diagonal. Yeah. This is the same, right? 2 are the same, 7 are the same. So this is mirrored by the diagonal. That is what is meant by symmetric. Diagonal matrix is that you only have entries on the diagonal. The remaining are 0. Okay. What about this matrix? Let's say you have 1, 0, 0, 0. This is 5. What about this? Is this diagonal matrix?
It's the upper and lower, right? It looks like a symmetric.
The diagonal must be symmetric also, yeah. But symmetric is not always diagonal. This is a diagonal matrix, only that the last entry here is 0. Okay. Right. The next one, identity. Identity is a diagonal matrix where the diagonal entries are all 1. That is identity. Any question on symmetric diagonal identity? Where do you see identity usually? Yeah, what do you remember about identity matrix? Anything? What do you remember about it? Say it again. 3D FBD. What does have to do with identity? Factor. I don't understand. Michael, what do you remember about it? Okay. Let's say matrix A, if I multiply it with its inverse, what do I get? Suppose the inverse exists. If I multiply A with its inverse, what I will get? It's identity matrix. It is identity matrix, yeah.
Yes.
Of course, it is identity matrix. Yeah. What else you remember on identity matrix? What if we multiply a matrix by identity matrix? What do we have? Huh? Huh? Come on. Matrix A multiplied by identity matrix. What do we have? Okay, now you multiply this
We get A.
with identity. Oh, what do you say?
We get A.
Yes, we get A. Any matrix multiplied by identity will become itself, which is why it's called identity. What about if we have a vector? Let's say we have vector v. Yeah, v. Let's say this is 2 and 1. Just 2 by 1 vector. What if we multiply identity with that vector? What do we have? Identity matrix multiplied by that vector. What do we have? Huh? That vector itself, correct. Yeah, it will be that vector itself. Huh? Yes. What if we multiply this is a times I becomes a, right? What about I times a? The same. A also, right? Yeah, it's the same. Okay. Upper triangular, as you can see, diagonal is there. The lower part is 0. The upper part is not 0. Lower triangular, easy to see, and this is a banded matrix. Okay. So this part is empty. You have 3 non-empty diagonals. That's banded. Any question?
Will we use the banded?
Very rare to be used. Yeah, very rare. Okay, let's say I have matrix A to be a diagonal one. Okay, this is A11. This is A22. Okay, can you get the inverse of this matrix? What is its inverse? How do we get the inverse? Okay. Huh? No need 3 by 3. Let us have 2 by 2. What is its inverse?
A22 0 0 A11
Say that again.
A22 0
Where? Here, A22 here.
left side, yeah. 0
0
0
0.
A11.
Okay, you multiply this. What do you get?
One on the diagonal.
A11 times A22, and then 0 times 0. Yeah, so you have A11 A22, right? So this one multiply that 0 0. Okay, 0 times this one, we get 0. A22. Okay, so is this 1 and 1?
No.
Huh? Maybe. What do you say? Maybe. Why? Is this 1 and 1?
No.
If I have the A in here, 2 by 2, yeah. No. Let me put it here lah. if the A is 3, 0, 0, and this is 7.
Oh sorry, lupa sir. Inverse-nya harusnya dibagi sama seperakali.
You just see the Google, is it?
Yes. I've been looking for it. I mean,
So if you use this as the inverse, then you will have 21 and 21 in here. Yeah? So the inverse is just the 1 over of the diagonal. So that's wrong, yeah. Okay, this is wrong. So I remove this. Okay, you get it? Any question? Clear? Yeah. Okay. So the next thing is we have identity there, permutation matrix. So when you have a permutation matrix, you multiply the matrix with itself, you will get identity. That's permutation matrix. Okay, and then you will use permutation matrix if you want to swap the row and the column of a matrix. Yeah, just switch the row and column. We will see later an example of permutation matrix. Yeah, this is another, the third property that we have here is a property of symmetric matrix, which is you multiply, the transpose of symmetric matrix is itself, okay? Which is why it is called symmetric. Okay, understand? Yeah. The transpose of symmetric matrix is itself. Yeah, Brian, why are you so sleepy? What time you sleep? You always sleep every time we have a class. Skew symmetric. Yeah, the skew symmetric is here. So the transpose is the minus of the matrix. Okay, that is called skew symmetric. This is an example of skew symmetric. So that means you can see the upper and lower triangular have different sign, and that's skew symmetric. Okay, let's say you have the top part plus, bottom part minus, or bottom part plus, upper part minus. Yeah, it has to be symmetric, but then the top part and bottom part different sign. That is called skew symmetric. Okay, if it is symmetric, then all have the same sign. Yeah. The next one, orthogonal matrix. Orthogonal, the transpose of it is the inverse. The transpose, it's the inverse. Okay, where is my eraser? An example. Yeah, you check this one multiplied by its transpose, what do you get? You try. Yeah, what is the transpose of it?
Oh, become column.
Yeah, this is cosine theta minus sine theta, and this is sine theta cosine theta. You multiply this, what do you get? You get identity matrix. Yeah, of course, identity, because I'm saying that this is an example of orthogonal matrix, right?
Oh iya. Ini ya.
Huh? See?
Oke, salah lihat.
Okay, multiply them. Cos theta sin theta minus cosine square plus sine square. Okay. Cos square theta plus sine square theta. Okay. This one, sine cos minus sine cos. It's 0. Cosine sine minus sine cos. It's also 0, right? The last part, sine square plus cos square. Oh, so you have what? 1, 0, 0, 1. Yeah.
Oh iya.
Any question on this? Okay, let's move on. Diagonal matrix, we discussed it just now. Yeah, the 3 diagonal is the banded one. Lower and upper, also we discussed that just now. Problem. Number 15 first. Is this a symmetric matrix? Huh? True, right? Yeah. Why is it true? Let me hear your reasoning. Why is it true?
Triangle mirrors the top.
Yes. Okay. What about this one? Is it skew symmetric?
Gimana? Yes.
Why is it yes?
The minus.
Yeah, that's correct. Yeah. Before seeing the transpose, the easiest way to see whether this is skew symmetric is that you check whether the upper triangular and the lower triangular have different sign, but their magnitude is the same. Okay, this is 1, the upper one also 1, but it's minus, so it is skew. So let's say if you have a matrix, okay, this is yeah, is this symmetric?
Yes.
Yeah, symmetric. Yeah. How do you make it skew symmetric?
You swap the sign on one of.
Swap the sign. So I put this minus there, it becomes skew symmetric. What if I do this? Is this skew symmetric?
Yes. Yes.
Why?
Still.
This is minus, some is plus, right? We have minus here, some are plus.
Still, because the signs are still reversed.
Okay, the important thing is that the sign of each element are reversed. Okay, so this is skew symmetric. Clear? Yeah, in fact, this is coming from your homework, which I will not share in the weekly lectures. Okay, number 17. Discuss this one first, yeah. Is this true or false? This matrix satisfy this equation. What do you think? You know how to do matrix multiplication? You know, right?
Yes.
Yeah, so I can ask you this.
A kali A.
Yeah, is this true for this matrix?
Supposed to group it or just
No, we say true or false, but I wanted to prove it, right? Here in this class. When you are doing the online quiz, you can just say true or false, but we are discussing the concept now. Johan, what do you think? Michael?
Plus square.
Okay, see here first, yeah. Before coming to that, this is an introduction to that. If I have A to be 1, 0, 2, 3, and then B is 1, 2, 3, 4. If I do A square, what does it mean A square? This is A times A, yeah? Which is 1, 0 and 1, 0, 2, 3, which is 1, 0, yeah? So 2, 6, this is 8, 0, 0 also here, 0 and then 9. So that is the A square, yeah? Now what about A times B?
AB.
You multiply them?
First one is 1.
1,
And
second one, 2, 11, 2,
4, 12.
or 12. Huh? 16, yeah? 4 and then 12, so 16. Okay. What about B times A?
Times A square.
Okay, let's do it.
1, 4, 5.
1, 4, 5, 3, 8, 11, 0, 6, 0, 12. Okay. Are they the same? No. So that's what happened with matrix, yeah. AB is not necessarily same with BA, but for some cases they can be the same. So let's see what happened if we multiply A plus B with A plus B. This is A plus B square, yeah? What do we have? This is A times A, okay? And then A times B. And then B times A. And then B times B. So finally you have A square plus AB. Yeah, the problem is here, the problem in there is that it says 2AB. So the right side says AB equal to BA. So you just have to check that. Is AB equal to BA or not for that matrix? If it is the same, then this is true. Okay? Any question? But I don't get the answer yet because I haven't compute. But you can use MATLAB now. Can you open your MATLAB? Open MATLAB and see whether they are the same. Well, this is the moment you use MATLAB a lot. Just be ready with the MATLAB. MATLAB, are you opening the MATLAB? So, What's the result? Come on lah, why it takes so long?
Loading, sir.
You use MATLAB, right?
Yeah.
Why slow computer?
Hello, sir.
But this is recorded into YouTube, and I said your computer is slow.
Yeah.
How do you check?
Huh? Just encode it. Encode it.
The quickest way to check in MATLAB whether they are the same is that. What do you do in MATLAB? You perform A times B minus B. Yeah, if you get 0, they are the same. With the non-zero, they are not the same. Don't check by your eyes. You got it?
So false.
False, yeah. So it is false. Johan, what's the result? Huh? False. Loading. MATLAB.
Coba. Tambah yuk. Kita tulis pengusia semua ya.
Brian, what's the result, Brian? Say that again. No, are they the same or not? They're not the same. Okay, they're not the same, then this is false.
They're the same.
Anyone consistent with the result? Is it Michael? Still loading? Okay, then in that case, let us move on to problem 18. You multiply this to the A from the left side. Is it true or not? Column 1 and 2 switch. Is this true or not?
Or
You can use MATLAB, you can use MATLAB to write it, or by hand calculation also can. If you want to use MATLAB, then you have to register 9 symbolic manipulator variable.
hold on. Just use random. Just use random number. Hello.
Oh, okay, can. But if the random number includes 1, then it will be confusing. They have to be different. All of them must be different.
1 until 9.
1 until 9. Okay, someone do it in here. Zero, 1, 1, 0, 0. Okay, I will waiting for you from your MATLAB. What about the results?
Yes.
Switch. It is switch. Okay. What do you see in the manual computation in here? What you can see?
Kalau dikali Nanti
The zero
yeah,
will be applied to
first and third.
the first. Yeah, whether you multiply this one or that one, yeah, this one will be all zero. So it means it only take the second one, yeah.
Oh,
Okay, you take the second one. In here also the second one. This is the second one also. Okay, where is my black one?
Mau diatur.
iya.
This is 8 to 1, 8 to 2 here,
Oh ya.
8 to 3. Okay. For the second row here, you use the second row here and multiply with all the columns, yeah. For the second row, you get the first element. Yeah, all of them are the first element. A11, A12, and then A13. Yeah. For the third row, you get the last element. A31, A32. Is this switch between column 1 and 2?
Yes.
Column 1, where's column 1?
Oh,
Row.
row.
This is row switch.
Ini.
The question asks for column switch or not.
Row deh.
No, right? Okay, let's see again. Yeah, let's see again. The first row that we have here, the first row, yeah, you will multiply this first row with all of the columns.
Yeah.
Okay, and then you will fill up the multiplication from here to your first row. Okay, the first row in here, multiply the first column, you get the first element, right? So you multiply this with this column, that column, that column, you will get the 3 elements to the right. Okay, and based on this, for the first row, you will take the second element of this column. Yeah, second element. So 2, 1, 2, 2, and 2, 3. Second element. You take the second element there. Okay. So basically, when you are doing multiplication from the left side, you will switch the row, not the column. If you want to do column switch, what do? You put this on the right side. You will switch the column.
Oh iya.
Sean, any problem on this? What's the problem? Which part that you don't understand? How to multiply?
Yeah.
Okay. You see this 8 to 1, yeah? We get this by 0 multiplied by this plus 1 times this plus 0 times this. Then you get this. Okay, now go to the second element. Yeah, second element, how you do it? 0 times A12. This here. Okay.
But that is
Yeah, it says from the left hand side. Then this one. So multiply with from the left hand side, you get row switch in this case.
Kalau misalnya di math,
Symbolic math toolbox, or if you can carefully see the number, you can use any matrix. So long that you don't confuse with the number. Any question on this? So the answer is what? Is it false or true?
false.
False, yeah. 17 false, 18 also false. We discussed this a lot, yeah. And so we don't have to discuss it again.
Skala.
However, the main thing that we want to say here is that if you want to add a matrix, they have to be the same size. Same size, yeah, for the matrix if you want to add them together. And then if you multiply a matrix by a scalar, then it means all of the element in that matrix is multiplied by that scalar, like this, yeah. For example, if I have a matrix A to be 1 0 0 1, if I multiply 8 times A, what do I get?
8 0 0.
It will be 8 0 0 8. Okay. Can I add P and A here? P plus A, can I? Yeah, P plus A cannot, yeah. They are not the same size. Can Nabil? Okay, next. Addition of matrix and scalar multiplication, not matrix multiplied by a matrix. Okay, is it true or false in this case? This is the first problem. Why don't you compute in MATLAB? You have
to write it down.
You have MATLAB, right? Yeah, compared to just staring the problem and then spacing out.
I don't believe the lots.
Correct? Okay, if it is A minus B, you have 3 in here, right? And then 4, and then 0, and then minus 4. So it becomes that one, yeah. If you plan to just do it by just staring it, don't do it too long. Now let me give you a quick tips if you want to check this without MATLAB. Yeah. My quick tip is that you subtract that first and then you multiply by 3, check to here. And then you subtract again another element, multiply by 3, check to there. Okay. Don't subtract and then picture out the matrix. After that you multiply, you will forget. You will forget the entry of the A minus B. Okay. You get what I mean?
Yes.
Yeah. Radit, do you understand? What did I just say? Can you repeat? My quick tip just now. My tips for solving this without using MATLAB. Huh?
What?
You don't listen, eh? What about this one?
False.
Yeah, already on the second element is false. Yeah, here, yeah, minus 2, it's false already. So when you see one element false, don't wait until the last element. Yeah.
Okay.
What about this?
Now becomes all B minus false.
Why is it false?
Dikali 2 ya?
Times 2.
Oh. Then it
Itu
is
correct. Dua kurang 10 6. Oke, benar. Itu 0 0 1 2. Oke, benar. 0 min 2 kali 2.
Okay. Yeah, it's true, yeah. So the answer is true. And any problem on this? Okay.
Soalnya kita harus kerjanya manual ya, nggak boleh method.
What?
For the homework.
Oh, if it is the one that is just the online part, you check on which part that is the submission part. Okay, if it is submission part, then you have to do hand calculation. You check it. This is problem 3, true or false?
It's
Apaan? Number 5.
nggak ada.
Number 4 now.
Number 4.
Iya.
Calculation of the expression. Yeah.
Kawan.
Cannot calculate.
Dulu. Yeah, it's faster. My brain is hurting.
Itu.
Titik.
Why you call that?
Single quote.
Oh, pangkat itu.
Pangkat.
Pangkat koma. Quote, single quotation. Belum juga. Oh, 5. Ada case. Why 9?
Okay, so it's false, is it? Yeah, you check. Let us see. 6 minus 18. Is it? Three times 2, 6 minus 18. So minus 12. Minus 12 times 3. How do you say 69?
3 times 9.
3 times 9.
Ini row. Kan itu 3 times 3 times.
27, okay.
7 minus 4.
23.
16.
Okay. So it's a false already, yeah. Okay.
False. Yes. 5 is.
Number 5 is true.
Yes.
Yeah.
Yeah. Transpose the transpose.
Okay. You get back to the original factor if you do that. Any problem for number 5? Michael? Number 5, are you okay? That this is true? You take the transpose of the transpose, you get back to your original matrix or original factor. Okay. Okay, number 6.
False. True. Good.
Is this symmetric?
True, sir.
True, yeah. So if it is symmetric, then the transpose it itself. Okay. What about number 7?
What? Tadi true.
True aja.
Johan. Number 7, is this true or false? Yeah.
AT minus.
Johan,
A is a skew symmetric matrix.
what is skew symmetric?
When the
Oh.
transpose is minus of the matrix.
Yeah. So how do you see if it is true? How do you check it?
By C.
Are you taking the transpose?
A.
I think it's
What do you see from here that it is skew symmetric?
The upper and
Yeah, the sign change in the upper and lower, yeah.
Yeah.
Okay. Are you following, Johan? You don't seem to follow at all. Sean, any problem? No. Yeah.
7S is A.
What about problem 8 now?
4
So number 7 is true, yeah. 7 true. Number 8.
Wait.
let's
Hold up. Yes. I think yes. Yeah. True.
12. Okay. The last part. 15. Yes. I think it's true. minus 5 3 tambah
Kali S.
yeah, I think this is true, yeah, this one. Any objection on this? Another tip that I want to say, yeah, if you have a problem like this or this one, if the statement is true, you have to check for all elements. Don't just check 1, 2, or 3 elements. You have to check for all elements, because one of them could be wrong. Okay, let's say all 8 correct, 1 wrong, then this is false. Okay.
So we check until we find something is wrong or
Yeah,
everything is correct.
that's correct. Okay. If you find 1 wrong, then stop there, it's false. Okay, number 9. True or false?
A to the 8. A is a square matrix.
No. False.
Why false? This is true, right?
True, yeah.
A transpose, you take the transpose again of it.
I mean true, sir.
It's true, right?
Yeah.
So it is true or false?
What is a
False.
Square matrix is that row and column are the same. Same number of column.
False. False though.
False.
Why?
Karena it's
Because-
only true if A is a square matrix. Sebenarnya enggak ada semuanya.
Correct, yeah.
3 times 2 gitu kan.
This is true, yeah. That's not this one true, right? So it applies to all kind of matrix.
Emang salah.
Kayak kemarin ya, Sarah, yang akan nanya ini.
Yeah. Okay. So based on your experience, I think we better discuss the concept here, yeah. Okay. Which is why don't get sleepy in the class, yeah. You will get lost. You get lost. Wow, matrix multiplication.
Wah.
The concept we discussed it already, yeah. The matrix multiplication we discussed it already. So let's move on to the problem.
Yeah.
Yeah. Yeah, this one. Is this exist or not?
The
product?
The result. Matrix is a
AB transpose, is this exist?
yes.
Why?
What? Wait.
Now I'm asking why AB transpose exists. What's the reason?
Because the multiplication of matrix can
Because it has the same amount of
size
row
of
and
Ah,
column.
correct. This one. Same size. Yeah. The product exists because it has the same size. Okay, in this case, but that is sufficient, yeah, sufficient condition for it to have the existence of the product. However, you can also multiply with a matrix with different size, yeah, as long as the number of columns in the first on the left matrix the same with the row of the second matrix. No.
Row and column juga.
Let's say, can you multiply A and C? A times C.
No.
So from here, ya.
Ya kan? Kalau transpose of C bisa.
Iya, betul. Dua juga.
Where's the eraser again?
Row sama column nggak sama, tapi kan row A sama column.
The number of harusnya jumlah row sama kolomnya sama, terus number of angkanya itu juga harus sama.
Enggak juga.
Row and column gitu. Iya.
Iya,
Bukan row and column.
Row kali kolom. Kalau row-nya ada 3 angka, harus kali kolom yang ada 3 angka.
C
A
A.
sama C bisa.
Enggak bisa. Bukan sama sih aja nggak bisa kalau sekarang.
Okay, so is this possible? C times A cannot ya. Yeah. 3 times 3 okay ya. 0 times 4 okay, but 2 it doesn't have pair on it ya. So non-existent.
So the row and the
Karena
column
elemennya
must
nggak
be the same.
Elemen di row-nya 2.
Row and column.
Kolomnya
The
3.
row of the first
elemennya
matrix
sama.
must be the same column.
Di kiri kolomnya.
Ya.
Kolomnya elemennya harus sama.
Rule-nya gitu ya?
Ya.
Rule-nya gitu.
That's the rule. So A times C 3, 2, 4, 1.
Tapi C sama D transpose bisa.
Lu masukin ke MATLAB bisa nggak dia?
Ya bisa. Nggak bisa.
This one,
Nggak bisa.
Oh iya bisa.
Oh, bisa bisa.
why?
Dia
Bisa.
nggak-
3
Karena
times
sama
3
kolomnya.
can.
Ya,
Oh iya bisa.
This one can ya.
Oh iya. Di atas semua.
3 times 3 9, 2 times 4 8.
Iya.
So it is 17
Visual.
0 0. 3 times 2 6 plus 2 become 8.
Tersegiri.
So over here it has to be what? M by N, and then over here it has to be N by P. So M and P, they can be different, but this has to be the same. Number of columns of the left one has to be the same with the row
Oh.
of the right part. Yeah, is this clear?
Salah lihat.
Number 11.
False dong.
Oh, start apa?
2 times.
Iya terus. Enggak 3 times 2.
Ya. Wait. Number 10 first. Wait. Number 10 first. Number 10, is this correct? Is it true? Number 10 is true. Okay, now number 11. Number 11, you have CD transpose, and C is what? This is 2 by 3. D is 3 by 2. Okay, you can multiply them. However, the size is 2 by 2.
Resulting size-nya tuh
The resulting size is 2 by 2. Okay, so the size depends on row of the left and column of the right side. This will be the size. You just multiply them. 302,
Kolom
401, and then you multiply by
4.
so it becomes 18, 0, 10. So it becomes 8. Yeah. What about this? 15, 0, 30, 36. So it becomes 41. Yeah. 24, 0, minus 5. And then 20, 0, and then yeah, it's 2 by 2. So actually, to answer this, you don't have to compute the result. You only need to check the size by using this. Okay. Next one. Number 12. Is it true or
The
false?
evolution of A times A transpose is the inner product A times A T 26. Row times column.
Evaluation of this.
Inner product is the dot product. Yeah. Inner product means dot product. What do you think?
A transpose nya dia row row jadi kolom, row jadi kolom, row jadi kolom.
Cara ngedot produk itu gimana?
Bentar, ini kalau ditranspos
Iya
jadi
di MATLAB gimana Pak?
dot itu gua pegang.
Oke, titik itu juga
bentar, weh. Transposnya dia tuh dirinya sendiri ya.
Okay, let's see here ya. Let us discuss the dot product. Students, let's say you have a vector v which is v1 and then v2. Dot product of this, what is the dot product?
Side
Dot product or inner product ya. Is defined as v transpose times v, which is v1, v2, and then here, which is what? Plus. And this is what? Scalar or vector? Scalar or vector? The result? Yang benar cuma dia. Scalar.
Scalar Bang, aduh.
Oh, come on. This is scalar. Element square, right? Plus element square. So it is scalar. The result of inner product or dot product has to be scalar. Now, what if I do v times v transpose? What do we have? v1, v2 multiplied by, what do we have? v1 square, and then here this one. Okay, so are these the same with this one? No. The result of this product is a scalar or a matrix? Matrix. And so the result of this A times A transpose, is it scalar or matrix? Matrix. Okay, it's matrix. So it is false or true? False. Okay. Oke ya, cocok kau rasa ya. What's that? Kau rasa bahasa apa? Number 13. Any question again on number 12?
Kenapa nggak yang bilang yang buat itu yang atas?
This one?
Ya.
Huh?
Tinggal buat gitu.
Yes.
Kenapa nggak di
Why? But because that's how we multiply matrix, right? v1 times v1 plus v2 times v2, and that's it. What else you want to multiply? We have nothing else to multiply, right? Any problem? It seems we have problem.
Yes sir. Dot product ini di MATLAB gimana sir?
Dot product in MATLAB we just multiply transpose with itself.
Oh.
Okay, let me get it to MATLAB ya. You have MATLAB now in your computer? Yeah. You define a vector, let's say p equal to 1 and then 3. Okay, define that in MATLAB. If you want to do dot product, and then you just write dot p comma p. Okay, or another thing you can write is that p single quote multiplied by p. You get it, Sean? Yeah. And then you just you can check p multiplied by p transpose. What do you get? Is it a scalar or a matrix?
A times E transpose.
Matrix, right? Yes. So that's how you do it.
Kalau dot A itu.
No, the dot product is this. This is how you get the dot product.
Oh, baik. Yang balik.
Okay, anyone still have problem with number 12? Okay ya. So we will discuss until number 14 and then we stop the class ya. Number 13.
Is constant.
Times apa?
Oh, enggak sih itu ya.
Bisa itu
Jadi 3 kali 1.
Can you multiply C times the D? No, cannot, right? So the answer is false. Yeah, because this operation cannot be done. Only this one can be done, yeah. So number 13 is false. What about number 14? No, the answer is false, yeah. Correct, yeah. Yeah. No.
Ya,
Both are matrix.
kali satu kali jadi satu.
The result of these two are both are matrix. Yeah, but then they are not the same size. Okay, what's the size of B transpose B? Hah? Yes, it's 2 times 2 ya. What about this one? 3 times 3. Yeah.
Kalau kiri.
Okay. Unless if this is square matrix, then this is true. Okay, if it is square, it is true. Alright, so it ends our class today. So I'll see you again on Thursday. Yeah.